All right, everybody. Chem 3276, this is your last experiment before your practical final. This experiment is one in which you are evaluating samples to determine their Km and Vmax. So kinetics analysis, or kinetics basically. So if you look at your procedure, you will see, and I'm going to share this in just 1 second, share screen, nope, share screen. There we go. If you look at your procedure in part 1, you'll see ion exchange chromatography sample 1, sample 2, sample 3, sample 1 for affinity chromatography sample 2, affinity chromatography sample number 3. Now, many of you, and maybe I don't think anyone has their ion exchange chromatography sample. Don't worry about that. I've provided y'all with, or I will provide y'all with, samples labeled A, B, and C. Okay, you are going to use these for this part of the procedure. This part of the procedure consists of determining what is the optimal amount of enzyme to use in order to go on to part B. So for, let's say, sample A, you are going to do a total of 4 different trials. You're going to measure the absorbance at 340 nanometers when you have 15 microliters of this, plus 150 microliters of lactate, 150 microliters of the NAD+, and whatever volume of caps is required to get that to a total of 1,000 microliters. You will do your calculation to determine, well, you'll measure your delta A340 per minute. Then you'll determine your micromole per minute, so your units of activity, and then you'll determine your micromole per minute per unit volume. So whatever this is right here, you will divide that by 15 microliters and get that. Then you will determine this value, divide that by 20 microliters. The idea is you want to figure out which which volume gives you the most activity per unit volume. So what we're basically doing is we're coming up with a ratio of units per microliter. So do you need 15 microliters of your enzyme added to each sample, or do you need 30 microliters? That's what part A is there to determine. So you will do that with A, B, and C. You will also do that with, just a second, your 3 affinity chromatography samples. In the event that you do not have your affinity chromatography samples or do not want to use them, you have samples D, E, and F. I did this procedure today, and I was successfully able to complete it with sample A. And since A, B, C, D, E, and F all come from something similar to A, I'm confident that it will work for y'all. Now, with that said, once you have completed part 1, you'll go on to part 2. And in part 2, what you're going to be doing is you're going to be varying your caps volume. You're going to have used part 1 to figure out that, hey, I need 25 microliters, as an example, of my enzyme added to a reaction. What I'm going to be varying amongst trials 1, 2, 3, 4, 5, and 6 is my NAD+ volume. So I'm varying my substrate concentration so that I can then put together Michaelis-Menten and Lineweaver-Burke plots. This volume, this total volume amongst lactate, NAD+, caps, and enzyme will equal 1,000 microliters. This number right here, this 25 microliters, is a hypothetical. You have to complete part 1 in order to get the value for part 2. So whatever you've determined for sample number 1 of your ion exchange chromatography, which is actually going to be this one right here, you'll put that in and you'll say, okay, well, it took me this much. Now I need to, say, add whatever volume of caps to get me to 1,000 microliters. Okay, so you're going to do that for the ion exchange chromatography samples as well as the affinity chromatography samples as a follow-up to part 1. Once you have completed that, if you look at the bottom here, you'll be able to generate both Michaelis-Menten and Lineweaver-Burke plots for each of the 6 purified samples. So you will have a grand total, or you'll be able to produce a grand total of 12 graphs. With these graphs, you'll then make an approximation of your Km and Vmax of lactate dehydrogenase. Okay, so I've set things aside. I've got plenty of caps buffer in these right here. I've got plenty of NADH, plenty of lactate to make it through the entire day. So there should be no issue or shortage of any sort of reactant or anything like that. I hope your experiment goes well tomorrow, and let me know if you got any questions. And now I'm ending the meeting.